Hi guys, welcome to today's video. Today we're going to talk about ANOVA. The contents of today's video are the introduction, the types of ANOVA, assumptions, the hypothesis, interpreting ANOVA, its limitations and applications, the future uses, and the conclusion. Introduction. ANOVA, or analysis of variance, is a statistical method used to compare the means of three or more groups. It helps us to determine whether the groups among the group means are statistically significant and whether any of the groups are significantly different from each other. ANOVA is widely used in research, especially in experimental settings, to test whether differences between groups are due to chance or whether they represent two differences in the populations being studied. It helps us identify which factors are contributing to differences in the groups being studied and can aid in developing new hypotheses for further research. Types of ANOVA. One-way ANOVA. One-way ANOVA is used to compare the means of three or more groups when there is only one independent variable being studied. This is the most commonly used form of ANOVA. Two-way ANOVA. Two-way ANOVA is used to compare the means of three or more groups when there are two independent variables being studied. It allows us to examine interactions between the independent variables as well as their independent effects on the dependent variable. Factorial. Factorial ANOVA is used to compare the means of three or more groups when there are two or more independent variables being studied. This method allows us to examine the effect of each independent variable on the dependent variables as well as their interactions with each other. Assumption. ANOVA assumes that the observations in each group are independent of each other. This means that the value of one group or observation does not affect the value of any other observation in the same group. ANOVA assumes that the data within each group are normal distribution. This means that the mean, median, and mode of the data are roughly equal, creating a symmetrical bell curve shape. ANOVA assumes that the variance of the data within each group is roughly equal. This means that the spread of the data is roughly the same across all groups. Hypothesis. Null hypothesis in ANOVA. The null hypothesis in ANOVA states that there are no significant differences between the names of the groups being compared. Alternative hypothesis in ANOVA. The alternative hypothesis in ANOVA states that there is one least significant difference between the means of the groups being compared. The ANOVA test statistic is a F statistic which compares the variance between the group of the variance within the group. ANOVA test calculation. Sum of squares calculation. The sum of squares is calculated by subtracting each individual observation in the mean of each group, squaring the result and adding up all the resulting values for each group. F statistic calculation. The F statistic calculation is calculated by dividing the between group mean square by the varying group mean square. Mean squares calculation. Mean squares are calculated by dividing the sum of squares by the degrees of freedom. P-value calculation. The p-value is calculated using the F distribution and the degrees of freedom from the numerator and the denominator. Interpreting. Interpreting the p-value. The p-value indicates the probability of obtaining an F statistic as extreme as the one calculated, assuming that the null hypothesis is true. If the p-value is smaller than significance level, we reject the null hypothesis and conclude there is a significant difference between at least two of the groups. Understanding F statistics. The F statistic measures the ratio of the variability between groups to the variability within groups. The larger the F statistic, the more likely it is that there are significant differences between the group means. Post-HOC test. Tukey's HSC test. Post-HOC tests are used to determine which specific groups are significantly different from each other, following a significant result in the ANOVA test. Bond-Ferroni test. The Bond-Ferroni test is another post-HOC test that adjusts the p-value for multiple comparisons to reduce the risk of a type 1 error. It is more conservative than Turkey's HSC test. Turkey's HSC Turkey's HSC test is a post-hoc test that measures all possible pairwise comparisons of the means of the groups being studied. It is one of the most commonly used post-HOC tests in ANOVA. The practical application. Completely randomized design. It is an experimental research design in which subjects are randomly assigned to different groups. ANOVA is commonly used to analyze the results of this type of experiment. Randomized block design is another experimental research design that attempts to remove variability from the data by grouping similar subjects together. ANOVA can be used to analyze the results of this type of experiment. Latin square design. Latin square design is an experimental research design in which each subject is exposed to each treatment a filter number of times, with research treatment occurring in a different order. ANOVA can be used to analyze the results of this type of experiment. Regression analysis. Testing regression coefficients. ANOVA can be used to test the overall significance of multiple regression models and to compare the means of different groups within a regression model. Model fit assessment integration. ANOVA can be used to test for goodness of fit of regression models. Limitation. ANOVA is sensitive to violations of assumptions such as normality, independence, and homogeneity of variance. Violations of these assumptions can result in incorrect conclusions. Limitation. Outliers in the data can heavily influence the results of ANOVA, making it less reliable. ANOVA requires a large enough sample size to ensure that the results are reliable. If the data does not meet the assumptions of ANOVA, other statistical tests such as non-parametric tests may be more appropriate. When losses are proportional to the square of the differences among the unknown population means, it is optimal. Otherwise, it may not be optimal. When losses are proportional to the absolute values of differences among unknown population means, for example, expected losses are minimized during using a test that uses the absolute values of differences among sample means. It is designed to be used with data from a normal distribution, and while it is extremely reliable, it may not produce exact p-values when the data from distributions with heavier tails than the normal. When observations are done from non-normal distributions, even when the analysis of variance yields almost exact p-values, it may be less powerful than the corresponding permutation test. In conclusion, ANOVA is a statistical method used to compare the means of three or more groups and to determine whether differences among the group means are statistically significant. It is widely used in research to test hypotheses and to identify factors that contribute to differences in the groups being studied. ANOVA plays a vital role in many fields such as business, healthcare, and social science. It allows us to draw meaningful conclusions from complex data sets and provides a basis for further research and hypothesis testing. That brings us to the end of the video. Thank you for watching and do leave a like. Thank